We will use an holistic approach to understand the nature and requirements of a big data platform. But first we'll ask, what is big data specifically? How is it studied? And what do we want to achieve by working with big data? Let's start with two client examples from IBM's customers using big data. The first client is KTH, Sweden's Royal Institute of Technology, Sweden's leading technical university, where they analyze real-time data streams to predict traffic patterns. The goal of this project at KTH is to combine traffic data from urban congestion with other data to take the ability to predict and improve traffic flow to the next level. Today the system collects a great deal of useful data, but researchers were looking for a way to gain more insight from it. With a smarter solution, researchers could help the population of a metropolitan area decide, for example, the best time and method to travel from one place in the city to another, or when to leave in order to catch a flight at the airport. Researchers were alerted to the capabilities of IBM Infosphere Stream software and adopted it as part of their technology platform. This led to a collaboration where IBM employees would learn more about traffic research, and the researchers at KTH would get access to software which would enable them to concentrate on their research rather than on programming. Data is gathered from a number of different sources, including cameras at entries and exits to the city, GPS data from taxis and trucks, weather information, public transportation systems, and more. All the information is processed by Stream software, which can handle all kinds of data, both structured and unstructured. Based on previous experience and the data collected from instrumented measuring points, this intelligence system can make predictions on how long it should take to travel from point A to point B, give advice on alternative routes and alternative transportation systems, and improve traffic flow in the metropolitan area. This approach enables researchers at KTH to analyze large volumes of streaming data in real time and can help transform the vision of smarter traffic into a real solution. When the solution is fully implemented, it will lead to smarter, more efficient, and more environmentally friendly traffic in the metropolitan area. In addition, the solution can be replicated in other areas worldwide. It also provides new insight into the mechanisms that affect a complex traffic system. What makes it smarter? Intelligent, handles large data streams and data other than pure traffic-related data, such as weather, to enable researchers to analyze and predict traffic faster and more accurately than ever before. Instrumented, gathers data from a number of different sources, including cameras at entries and exits to the city, GPS data from taxis and trucks, weather information, public transportation systems, etc. Interconnected, enters gathered data into the Infosphere Stream software, which can handle all types of data, both structured and unstructured. In the second example, IBM has been collaborating with the University of Southern California Annenberg Innovation Lab, part of the Journalism School, to explore how technology can be used by organizations from news outlets and journalists to movie studios and retailers in order to better understand, respond, and predict public sentiment. One of the ongoing projects is to do real-time sentiment analysis on Twitter data related to the Republican primary debates and presidential debates. The challenges include how to process, filter, and analyze millions of public Twitter messages, how to determine the sentiment of each message, predict debate winners and changes in candidate popularity, How does the system do its work? The Streams application receives all the tweets related to the Republican primary through a direct connection to the Twitter Firehose, 100% coverage, versus the Twitter Public API, only 1% coverage. Twitter-specific natural language processing is performed on each tweet to analyze its sentiment and aggregate the data for each candidate. The output is then displayed on a web-based user interface. The data is archived to be able to rewind or fast forward to a particular point in time. Natural language processing is based upon work done at the University of Pennsylvania, the Penn Tree Bank Project, Stanford University, Carnegie Mellon University, and others. The benefits of this approach provide real-time public feedback on candidates' answers to debate questions, early prediction of debate winners based on public opinion, independent assessment of who won the debate based on public opinion versus just the opinion of political analysts,